All right, guys, here's the infamous problem 11 we're getting a lot of questions on. I'd say about half the guys we've gotten assignments turned in from so far have had issues with this one, so we'll go ahead and look at it. I think it was an error in the book just based on what the right answer is. It doesn't really make sense, but if you get this answer, at least you'll know you're doing the math right. So we're talking about question 11 here, and it says, find the efficiency of a DC generator being driven by a 12.5 horsepower motor and delivering 68.9 amps at 220 volts. So if it's a generator, it's taking mechanical energy in and putting out electrical energy. So the work in is going to be this, and then we're going to have to find out what the wattage is and convert that to horsepower based on what's delivering. So if it's delivering 68.9 amps at 220 volts, then if we multiply those two together, we'll be able to get what the wattage is. So 68.9 times 220 is going to give us 15,158 watts. And that's what the machine is putting out. What's coming in is 12.5 horsepower of mechanical energy from whatever it's being driven by. So let's go ahead and convert that. So 12.5 horsepower, if we have our 746 watts per horsepower, we'll multiply that by 746. So 12.5 times 746, and that gives us 9,325 watts. So that's the work in. So if the work in is smaller than the work out, kind of doesn't make sense, but let's go ahead and just get our efficiency formula and prove it to ourselves here. So if we know efficiency is the work out divided by the work in, then the efficiency of this is going to be 15,158 watts divided by 9,325 watts. So if you calculate that, it's going to give you 1.625, or if we round right, 626. So if we change this over to a percentage, we're going to move that over two places. That gives us 162.6% efficiency. Now, that's a hell of a machine, but I'm guessing it was an error. One thing that Jason Healy pointed out earlier in email, that it would make a lot more sense if the voltage was 110 volts, which I agree. So if you got 162.6% efficiency, doesn't really make sense, but that is what the answer should be based on the way that the book worded the question. And I'm kind of glad that they left that in here. I did notice it when I was solving them the other day, and I think it kind of a good talking point because it kind of makes us think about it a little bit closer. If we do it, whatever number gives us a smaller percentage and don't really consider which one's in and out, we get kind of complacent just filling in all these problems. It's easy to miss stuff like that. And we did have a couple guys turn it in that divided it the other way, probably just because the numbers made more sense. But if you really read the way the question's written, what's coming in is the 12.5, and the electricity is what's going out. So if you got 162.6%, good job, keep it up. Doesn't really make sense because you shouldn't have a machine that's more than 100% efficient. But if you have any other issues, go ahead and email us and we can send these out pretty quickly and go over some of the stuff together. All right, so keep up the hard work. We got another hour and a half before you guys need to have everything turned in. And if you have any issues with it, just give us a call. All right, thanks.